Okay, this is an example of a crest vertical curve. So we're given some information. We have a 600-foot vertical curve connecting a plus 4% grade to a minus 2% grade at station 25 plus 60.55. The elevation at that point is 648.64 feet. So we are asked typically to find some critical pieces of information for the vertical curve. In this case, let's calculate the location and elevation of the PVC, the PVI, and the PVT. And just for fun, we'll also find several additional pieces of information, which are the elevation on the curve at two locations. We'll say 24 plus 0, 0, and 27 plus 0, 0. Okay. So those of you who have been in the class for a while, you will know that usually the first thing we want to do is draw the picture. So I'm going to draw a sketch just illustrating this crest vertical curve, approximately to scale, but not exactly. So we want the initial grade to be plus 4%. And then we want the final grade to be minus 2%. So you can help yourself by drawing things approximately to scale. So if you remember that if the stationing is moving from left to right, the point of vertical curvature, which is the transition from the tangent to the curve, is the PVC. And this is, of course, the PVI, point of vertical intersection. And then when the curve returns to the tangent, that's called the PVT, or point of vertical tangency. So now if you'll bear with me to approximately draw in the vertical curve perfectly smoothly, something like that. So that's the vertical curve, and we know from the information that we've been provided that this horizontal distance is 600 feet. So when you're drawing the picture, you want to make sure you draw it large enough so that you don't get stuck running out of room. So just to label the pieces of information we know that the PVI is station 25 plus 60.55. Now, in this particular problem, of course, we can calculate the stationing of the PVC and the PVT because we know the length of the curve. So the PVC is simply 300 feet, or L over 2, subtracted from the station of the PVI. So you can verify this for yourself, but the station of the PVC is 22 plus 60.55. And then can you quickly calculate the stationing of the PVT? And so you basically add 300 to this, so you get 28 plus plus 60.55. Okay, so we've got the stationing. We're going to do a couple things where later we're going to calculate some parameters at station 24 plus 0, 0. So I'll just approximately place those in here just to remind me. So there are a couple things that we want to do. We know the elevation of the PVI is 648.64. So the question I have is, can we calculate any other elevations? And in fact, yes, we can. We can calculate the elevation at the PVC. So that's going to be 648.64 minus L over 2, which is 300 feet, times 4%. So the elevation of this point at the PVC is 636.64. And then we can do the same thing. We take the elevation that we know here at the PVI and we subtract the vertical difference between those 2 points moving in that direction. So we can calculate the elevation at the PVT. And so that's 648.64 minus 300 times the slope, which is 2%. So the elevation there is 642.64. So now what we want is to calculate the elevation on the curve at the PVI. Okay, so if you recall, this distance here is the maximum because the curve is symmetrical here. The maximum vertical distance between the curve and the tangents in this case is called y sub m. So in order to calculate that, we first need to calculate A, which is the absolute value of the difference in grade. So it's the absolute value of G2 minus G1. And if you remember, these absolute value calculations are done in whole percentages. So G2 in this case is minus 2, and then G1 is plus 4. So this value of A is minus 6 for this problem. So we can calculate the value of y sub m. Okay, so next we're going to calculate the elevation of the curve in the middle. And you might recall we called this y sub m, and we have a formula for that. AL over 800. So in this case, A is 6, L is 600 feet, divided by 800. So that is 4.5 feet. So that's this distance here. So then what's the elevation on the curve at the PVI? That's just the elevation on the tangents, which is 648.64 minus 4.5 feet. So the elevation here on the curve is 644.14 feet. So most of the problem is completed now. So the only two remaining items are to calculate the elevation at these two stations. And so the way that I like to think about solving this problem is to calculate this distance. And then what I'm going to do is I'm going to extend this tangent and then get a little bit crowded here. I'm going to calculate this distance here. So you might remember that another way that you could solve for the elevation at station 27 is to calculate this distance here moving from right to left. But just for consistency's sake, the way that I'll do this example here is to move from the left to the right. So I'll be calculating the vertical offset for station 24, which is this distance, and the vertical offset for station 27, which is this distance, using this plus 4% tangent as the basis. Okay, so starting with station 24, I'll just call this y sub 24 for the moment. And you might remember the equation that we use for this is a divided by 200L times x squared, where x is the distance from the, in this case, from the PVC, since we're moving from left to right. So a again is 6 divided by 200 times L, which is 600, length of the vertical curve. And then x is simply the horizontal distance from station 24 back to the station of the PVC 22 plus 60.55. And that distance you can verify is 139.45 feet. And that's squared. So the offset is 0.97 feet. And so how do we then calculate the elevation on the curve? So I'm simply going to calculate first the elevation on the tangent. So I'm going to go up, and then I'm going to go down. So the elevation at 24 is the PVC elevation, 636.64 plus x, 139.45 times 0.04 minus 0.97. So we're going from here up and down. And so the elevation at 24 plus 00 is 641.25 feet. And then follow the same procedure for 27. So again, I'm starting on the left. So y sub 27 equals a divided by 200L times x squared. And so our x is going to be a lot longer this time. And in fact, the distance is, if we go 6, distance to station 27 is 439.45 feet. And so all that is just 27 plus 00 minus this station, 22 plus 60.55. So y sub 27 is 9.65 feet. So now I can calculate the elevation at station 27 following the same model as I just did. So we start at the elevation of the PVC plus x in this case, 439.45. Also times 0.4. In this case, minus 9.65. And so the elevation is 644.56. And you can kind of look at this to make sure that it makes sense. So the elevation does fall between 642 and 648 as it should. So you can use the picture to help verify your solution. So that completes the Crest vertical curve example. Thank you for your attention.